In a surprising announcement on X, Elon Musk revealed that Tesla will be shifting its focus from battery-powered vehicles to hydrogen fuel cells. This decision comes as the company faces challenges in mass-producing its 4,680 battery cells, prompting Musk and Tesla to explore alternative, sustainable energy solutions. Alongside this, Musk introduced Tesla's new water engine, which is expected to play a pivotal role in this transition. This development raises some intriguing questions. What makes the water engine so groundbreaking, and how could it impact not only the automotive industry, but also other sectors? Stay tuned to see the latest technological innovations from Tesla's visionary CEO, Elon Musk. Elon Musk, the mastermind behind Tesla and SpaceX, has made a name for himself in both the tech and sustainability sectors. His relentless drive for innovation has led to groundbreaking advancements in the automotive and aerospace industries. Musk's vision for Tesla wasn't just to make electric cars. He sought to revolutionize transportation and accelerate the shift towards sustainable energy. Through Tesla, he's proven that electric cars can offer superior performance, making them more desirable than ever before. But Musk's ambitions don't stop there. With SpaceX, his goal is to make space travel accessible to everyone and to pave the way for human colonization of Mars. His relentless pursuit of these lofty goals has solidified his status as a leading force in modern technology. The water engine, however, is his latest venture, and the potential behind it is truly mind-blowing. Much like SpaceX's groundbreaking work in rocket reusability, the water engine has the potential to reshape industries. SpaceX's success in landing and reusing rockets has already had a major impact on the space industry, demonstrating Musk's ability to turn ambitious ideas into reality. When Tesla started in 2003, many doubted its vision for electric cars. Back then, electric vehicles were seen as impractical. Yet, through sheer determination, Musk delivered the Roadster, a high-performance electric car that proved electric mobility could be both efficient and desirable. Tesla didn't stop there. The company introduced models S, X, 3, and Y, each one advancing battery technology, range, and autonomous driving features, making electric vehicles an increasingly attractive option for consumers. Beyond electric cars, Musk has also been a champion for sustainable energy solutions. With products like the Tesla Powerwall and Solar Roof, he's helped create a more sustainable energy ecosystem for homes and businesses. Tesla's solar roofs integrate solar power generation with efficient energy storage, offering practical alternatives to fossil fuels. Looking back at SpaceX, the company has achieved remarkable milestones in space exploration. The Falcon 9 rocket, for example, significantly reduces the need for raw materials in rocket production, and the Starlink satellite constellation aims to provide global internet coverage. These innovations further highlight Musk's far-reaching influence on technology and sustainability. Now let's talk about the water engine. This technology is built on a simple but innovative concept, using water to generate energy. Unlike traditional combustion engines, which rely on fossil fuels, and electric vehicles, which depend on batteries, the water engine promises a cleaner, more sustainable energy solution. It works through a process called reverse electrolysis. Let's dive into what that means. Things are about to get even more interesting. Regular electrolysis uses electricity to break water down into hydrogen and oxygen. Reverse electrolysis, however, works the opposite way. It combines hydrogen and oxygen to produce electricity, with water vapor being the only byproduct. This process makes it a clean and eco-friendly energy source. Here's how it works. Water is introduced into the system, and an initial energy input splits it into hydrogen and oxygen. These are stored in separate tanks within the vehicle. When the engine runs, hydrogen flows into a fuel cell, where it splits into protons and electrons. The electrons generate an electric current that powers the motor, while the protons combine with oxygen to form water vapor. This cycle continuously repeats. Water turns into energy, then back into water, creating a sustainable and environmentally friendly energy source. Inside the fuel cell, protons pass through a special membrane and combine with oxygen from the air to produce water vapor. As long as hydrogen and oxygen are supplied, this process continues to generate electricity efficiently. But how does this water-powered engine compare to traditional and electric engines? The results are pretty surprising, so keep watching to find out more about Elon Musk's water engine. When we look at traditional combustion engines, they are only about 20 to 30% efficient, with much of the energy lost as heat. On the other hand, electric engines are far more efficient, with 85 to 90% of energy used effectively. However, electric engines also have their downsides. For one, they charge slowly, and over time, the battery degrades. The water engine falls in between with around 60% efficiency. While it's not as efficient as electric engines, it has a huge advantage. It's much cleaner and more sustainable. This makes it a promising alternative for a greener future. But that's not all. The water engine has the potential to go as far, if not farther, than traditional gas-powered vehicles. Imagine a car that emits only water vapor and doesn't leave you worrying about running out of power on the road. That's what makes the water engine so intriguing. Unlike electric cars, which require long charging times, the water engine can be refueled quickly, just like a gas-powered car. This combination of speed and eco-friendliness positions the water engine as a game-changer for the automotive industry. One of the major benefits of the water engine is its ability to reduce carbon emissions. Traditional engines release large amounts of carbon dioxide and pollutants, contributing to environmental harm and climate change. In contrast, the water engine only emits water vapor, making it a cleaner, more sustainable energy option. To put it into perspective, a typical gas-powered car releases about 4.6 metric tons of carbon dioxide each year. Switching to water engines could eliminate these emissions entirely. Additionally, environmental activists believe that urban air quality could improve dramatically without the nitrogen oxides and other harmful particles produced by regular vehicles. Electric vehicles are definitely cleaner than gas cars, but they're not perfect. Mining for battery materials, like lithium and cobalt, has its own environmental impact. Plus, if the electricity used to charge EVs comes from fossil fuels, the carbon savings aren't as significant as we might hope. Hydrogen fuel cells offer another clean alternative since they only produce water as waste, but hydrogen production often relies on natural gas, which still contributes carbon emissions. This highlights the complexity of finding truly sustainable transportation solutions. The water engine offers a promising step forward, helping to create a cleaner, greener future. Storing and transporting hydrogen is easy, but its low energy density requires high-pressure tanks to keep it stable. Tesla engineers have come up with an innovative solution to this challenge that's sure to impress. By using reverse electrolysis, Tesla's water engine could solve these issues more efficiently and cleanly than ever before. And we almost forgot to mention another important point: finance. The water engine could have significant financial benefits too. Let's explore that next. Switching to water engines could save a lot of money in the long run. Gas-powered engines require regular maintenance, such as oil changes and exhaust repairs, which add up over time. Electric cars, while needing less maintenance due to fewer moving parts, still face expensive battery replacements that can have an environmental impact. In contrast, the water engine's simpler design and fewer parts mean it requires less maintenance and has lower operating costs. These savings could make it a more affordable option for many, offering a cleaner and cost-effective alternative to both traditional and electric vehicles. The components of a water engine, like fuel cells and electrolysis systems, are designed for durability, potentially giving vehicles a longer lifespan. As the technology advances and becomes mass-produced, the initial cost of water-powered cars could drop, making them more accessible to everyone. However, transitioning to water engines does come with its challenges. For one, Tesla would need to make a significant upfront investment to build refueling stations, as existing infrastructure isn't equipped for water-based refueling. They may need to develop new stations or upgrade existing ones to accommodate the technology. This will require collaboration between governments and private companies to create a global refueling network. If successful, water engines could reduce our dependence on oil, leading to more stable fuel prices and easing tensions tied to oil supply issues. A shift to sustainable energy could also positively impact the global economy in the long run. On the bright side, this shift could generate job opportunities in new industries focused on water engine technology, manufacturing, and infrastructure. However, another key challenge Tesla faces is overcoming industry resistance to change. The current automotive infrastructure is deeply rooted in fossil fuels, from manufacturing to refueling networks. Many companies in the traditional sector may resist the move toward water engines. To address these challenges, Tesla can work with existing technologies, such as hydrogen fuel cell principles, for faster development and deployment. So, what does the future look like for Musk's water engine? Will it transform how we think about energy and transportation, or will it face too many obstacles? The automotive industry is closely watching Musk's announcement, knowing that this technology has the potential to disrupt the market. For widespread adoption, Tesla will need to develop efficient and affordable reverse electrolysis systems, build a reliable water refueling infrastructure, and ensure the technology is safe and dependable. If these challenges are overcome, the water engine could revolutionize the automotive industry and lead us toward a cleaner, more sustainable future. Key players in the automotive industry have had mixed reactions to Musk's announcement. Toyota and Hyundai, who have long been advocates of hydrogen fuel cell technology, have responded differently. Toyota views Musk's venture as a validation of their belief in hydrogen's potential, seeing it as a positive step toward greater investment and development of hydrogen infrastructure. Toyota has already made significant investments in hydrogen engine research. On the other hand, Hyundai has taken a more cautious approach to hydrogen research, and reports suggest they're not yet ready to invest heavily in supporting hydrogen and water engine technologies. Still skeptical about the water engine's feasibility? You're not alone. Even industry experts are divided on the issue. Some believe it could be a groundbreaking move that accelerates the transition to sustainable energy, while others express doubts about its real-world applications. Joseph Raw, a former U.S. Department of Energy official, argues that hydrogen-powered cars are among the least efficient and most expensive ways to reduce greenhouse gas emissions. He also pointed out that the infrastructure costs for a nationwide network of hydrogen refueling stations could be too high for any individual or government to shoulder. Additionally, over 100 scientists, led by Professor David Shawn from the University of Cambridge, criticized the use of hydrogen-powered vehicles for the Paris 2024 Olympics. They argue that these vehicles aren't as environmentally friendly as claimed, noting that hydrogen cars require about 3 times more renewable energy to produce than electric vehicles. Electricity is often considered a cleaner alternative to battery electric vehicles, but it's important to note that most hydrogen is still produced from fossil fuels, which weakens its green credentials. Perhaps Tesla's water-powered engine will address some of the concerns raised by critics. However, despite expert opinions, the final decision will lie with the public. Who will be the users and consumers? So, how has the public responded to Elon Musk's water engine announcement? Elon Musk's reveal of the water-powered engine has sparked excitement, curiosity, and skepticism. Tesla enthusiasts and environmental advocates have eagerly shared their hopes for cleaner, more efficient engines on social media. Many people are excited about the possibility of reduced emissions and the opportunity to redefine sustainable transportation. However, not everyone is convinced. Musk had previously dismissed the idea of a water engine, and now people are questioning why he's shifted from his earlier skepticism about hydrogen technology. But there's another challenge at hand. Keep reading to discover more. One of the major concerns surrounding this new technology is the creation of an entirely new refueling infrastructure. While gas stations are widespread and the electric vehicle charging network is rapidly growing, establishing a similar system for water-powered engines would require significant investment and collaboration. The success of this innovation will depend on overcoming a few critical hurdles. First, improving the efficiency and affordability of reverse electrolysis. Second, building a user-friendly refueling network. And third, addressing public concerns about cost, safety, and practicality. If Musk and his team can solve these issues, the water engine could revolutionize transportation and usher in a greener future. But this journey is filled with uncertainties. Only time will tell if this ambitious vision can become a reality. In contrast to the extensive network of gas stations and the rapidly growing electric vehicle charging infrastructure, the hydrogen fuel cell network is still in its early stages. Hydrogen refueling stations are relatively few and mainly located in places like California, Japan, and parts of Europe. While this existing infrastructure could support the use of water engines, which rely on a similar hydrogen refueling system, a major expansion is required to accommodate widespread adoption. The good news is that Tesla has a plan. According to company sources, Tesla intends to use its expertise in building EV supercharging stations to retrofit current EV stations with hydrogen refueling capabilities and create entirely new stations designed specifically for water engines. However, this ambitious goal will require substantial investment and collaboration with governments and private sector partners to ensure convenience and availability for consumers. The big questions, though, are how quickly this network can be built and what financial and logistical challenges need to be overcome. As Tesla moves forward with its water-powered engine, these concerns will need to be addressed. When it comes to rolling out the water engine, there are several significant challenges to tackle. These include the cost of building infrastructure, ensuring reliable hydrogen production and distribution, complying with safety regulations, and addressing public perception. Successfully integrating this new technology into the market will require overcoming all of these hurdles. Safety is, of course, a top priority when introducing any new technology, and the water engine is no different. We're about to reveal a crucial flaw in the water engine concept, so keep reading. While hydrogen is a clean energy source, it's also highly flammable and must be handled with care. Since the water engine converts water into hydrogen, it essentially inherits these safety risks. To minimize potential dangers, Tesla has put several safety measures in place. For instance, they've developed an advanced hydrogen storage system to keep hydrogen safely contained within the vehicle. These systems are designed to withstand high pressure and prevent leaks. They're also subjected to rigorous testing to ensure they meet and exceed the safety standards set by international regulatory bodies. By focusing on safety at every stage of development and deployment, Tesla hopes to position the water engine as a reliable and secure option. However, it's still unclear if these safety measures will fully ease the public's concerns. Building trust and securing public confidence will require ongoing communication and transparency about the safety features and protocols of the technology. Steps like public awareness campaigns and independent safety certifications could also help improve the perception of the water engine as a safe, reliable alternative. Next, let's consider the legal and regulatory hurdles. Hydrogen storage, transportation, and usage regulations vary by country, and Tesla will need to work closely with regulatory bodies to ensure they comply and secure the necessary approvals for the technology's widespread use. However, this is no simple task. The process often involves extensive documentation, rigorous testing, and ongoing discussions with regulators to address concerns and adapt to changing requirements. Without these efforts, Tesla would struggle to overcome regulatory challenges. But is it all worth it? Let's take a closer look at the case for the water engine. First, let's compare the water engine with hydrogen fuel cells. Hydrogen fuel cells are known for their high energy density, allowing for long driving ranges and quick refueling times. They also only emit water vapor, making them environmentally friendly. However, challenges arise when it comes to producing, storing, and transporting hydrogen, which is highly flammable and requires specialized infrastructure. Water engines, on the other hand, offer on-demand hydrogen production, which means they can store hydrogen more efficiently and reduce the risks associated with handling it. Additionally, water engines have the potential to integrate seamlessly with renewable energy sources, boosting sustainability even further. Electrolysis requires a substantial initial energy input, which can affect overall efficiency. Ultimately, the success of the water engine will rely on several factors, including overcoming technical challenges, building a reliable refueling infrastructure, and competing with existing technologies like hydrogen fuel cells and battery electric vehicles. We've already discussed the high costs associated with research, development, and investment for water-powered vehicles. But now you might be wondering about Tesla's potential earnings and that of potential investors. The market for water engines looks promising, though it won't be without its challenges. The good news is that the automotive industry is increasingly focused on reducing carbon emissions and embracing sustainable energy sources. Governments across the globe are setting strict emissions targets and providing incentives for clean energy technologies, creating a supportive environment for innovations like the water engine. Elon Musk and other innovators aren't alone in their commitment to sustainability. At first, water engines may attract early adopters and environmentally conscious consumers, but as the technology improves and costs drop, more people are likely to embrace it. Analysts predict that water engines could capture significant market share within the next decade, assuming Tesla can address efficiency issues, develop infrastructure, and scale up manufacturing. Tesla may also need to collaborate with both public and private sectors to ensure widespread growth. However, water engines won't be the only option on the market. They'll need to compete with established technologies like battery electric vehicles and hydrogen fuel cells. Each of these technologies has its own advantages and drawbacks, and consumer choices will be influenced by factors like cost, range, refueling time, and environmental impact. Aside from Elon Musk's determination and the innovation of Tesla's engineers, other elements will play a role in determining the water engine's market success. We're talking about government policies, technological advancements, and shifting consumer demands. Here's the catch. These factors are constantly changing. Water engines must evolve to stay competitive in this ever-shifting landscape. Ultimately, the success of water engines will depend on a combination of technological breakthroughs, strategic partnerships, and favorable policies. If these factors align, water engines could disrupt the automotive industry and play a key role in a cleaner, more sustainable future. To those who remain skeptical about this technology, let's take a quick look at how far we've come. The journey of engine technology started centuries ago with the invention of the steam engine in the late 17th century. Innovators like Thomas Newcomen and James Watt made significant improvements to these early designs, revolutionizing transportation and industry. Steam engines became the driving force behind the Industrial Revolution. So, who knows what the future holds for water engines? The Industrial Revolution sparked the rise of locomotives, ships, and factories. But by the late 19th century, the internal combustion engine began to emerge. Thanks to inventors like Nikolaus Otto and Rudolf Diesel, the four-stroke engine and Diesel's compression ignition engine set the groundwork for modern gasoline and diesel engines. These new engines provided greater efficiency and power, leading to their widespread use in automobiles, aircraft, and ships. The 20th century saw continued innovation in internal combustion engines, with improvements in materials, fuel injection, and turbocharging. These advancements helped enhance performance, fuel efficiency, and emissions control, solidifying internal combustion engines as the heart of modern transportation. However, growing concerns over pollution and the depletion of fossil fuels prompted the search for alternative energy sources. This brings us to the late 20th and early 21st centuries, when electric vehicles, EVs, began gaining attention. Electric vehicles offered a cleaner, more sustainable alternative to traditional engines, marking a significant shift in the evolution of engine technology. Companies like Tesla, under Elon Musk's leadership, took the lead in the EV revolution with breakthroughs in battery technology, range, and charging infrastructure. But the drive for alternative fuel engines began long before Musk's efforts. Hydrogen fuel cells, for instance, were developed in the 1960s, and NASA used them to power spacecraft during the Apollo missions. Despite their potential, widespread adoption of hydrogen fuel cells faced challenges like high production and storage costs, as well as lack of infrastructure. In the early 2000s, biofuels like ethanol and biodiesel, derived from plants and organic waste, gained attention as another alternative. While biofuels are renewable, their production requires significant agricultural resources, raising concerns about food security and environmental sustainability. Electric vehicles themselves represent a major technological shift. Early EVs, such as General Motors' EV1 in the 1990s, showed the potential of electric propulsion. However, issues like limited range, high costs, and insufficient charging infrastructure hindered widespread adoption. It wasn't until advancements in lithium-ion batteries and the development of comprehensive charging networks that EVs truly began to take off. A key lesson from the history of alternative fuel engines is the importance of infrastructure. Both hydrogen fuel cells and early EVs struggled because of the lack of adequate infrastructure. Elon Musk's plan to leverage Tesla's supercharger network for hydrogen refueling could help address this issue directly. While biofuels are renewable, they often consume more energy to produce than they yield. Musk is aiming to enhance energy efficiency with his water engine, optimizing the reverse electrolysis process to make splitting water and recombining hydrogen and oxygen as efficient as possible. In this historical context, Musk's water engine represents the latest step in the quest for cleaner, more sustainable engine technology. By building on the successes and lessons from previous innovations, Musk is pushing the boundaries once again. His goal is to overcome the limitations of earlier alternative fuel technologies while using the existing infrastructure and expertise from electric vehicles. If you're skeptical about the feasibility of Musk's water engine, just look at the history of engine technology. As the saying goes, necessity is the mother of invention. Now, let's look ahead. What does the future hold for water engine technology, and who are the key players? Apart from Tesla, many companies are exploring sustainable transportation solutions. Take Nikola Corporation, for example. While facing setbacks, Nikola is making significant progress with hydrogen-powered trucks and could become a potential competitor in the clean energy space. The future of water engine technology is an exciting one, and we're just getting started. Keep watching to find out what's next. These companies are focusing on the commercial market, which could pose a significant challenge to Tesla, especially in the long-haul trucking sector. BMW is also delving into water engine technology, leveraging its strong brand and engineering expertise. The company has been exploring hydrogen fuel cell technology, unveiling prototypes and committing to further research. BMW's move into the water engine market could increase competition, particularly in the luxury vehicle segment. Another key player is Rivian. For those unfamiliar, Rivian is an electric vehicle startup backed by major investors like Amazon and Ford. While it currently focuses on battery electric vehicles, its innovative approach and substantial funding could allow it to pivot toward water engine technology if market demand shifts. However, collaboration will be crucial for the rapid development and widespread adoption of water engines. Tesla has a history of forming strategic partnerships to advance its technological goals. Collaborations with other automotive companies, energy providers, and research institutions could accelerate innovation, help develop necessary infrastructure, and reduce costs, benefiting both the industry and consumers. The competition in the water engine space is likely to be intense, and Tesla's success will depend on its ability to leverage its technological expertise, outpace competitors, form strategic alliances, and adapt to changing market demands. Tesla can collaborate with leading tech companies, universities, and research institutions to access cutting-edge research, specialized knowledge, and advanced technologies, helping to accelerate the development of its water engine. Partnerships with universities at the forefront of hydrogen research could improve the efficiency and performance of Tesla's water engine. Collaborations with material science departments could lead to the creation of more durable and efficient electrolysis systems, while working with hydrogen storage and transportation experts could lead to safer, more compact storage solutions. Additionally, partnerships with tech giants like Google or Apple could integrate advanced software and AI capabilities into water-powered vehicles. To achieve true environmental sustainability, the hydrogen used in water engines can be produced through electrolysis powered by renewable energy sources like solar or wind power. Imagine homes with solar panels generating hydrogen fuel during the day, which is then used to power water engine vehicles. The potential applications of water engines extend beyond automobiles. Tesla is reportedly exploring how this technology could be used in aviation. Ships powered by water engines could dramatically reduce the environmental impact of global shipping, contributing to cleaner oceans and air. This is especially important as the shipping industry is a significant contributor to global greenhouse gas emissions. Water engines could offer a sustainable alternative for heavy industries with high energy demands, reducing reliance on fossil fuels and lowering emissions. This could have a major impact on sectors like manufacturing, mining, and construction, helping them transition toward cleaner energy sources. Water engines have the potential to revolutionize not just transportation, but also power generation and industrial processes, contributing to a greener and more sustainable future. Thank you for staying with us. Do you think water engines will define the future of clean energy transportation? Share your thoughts in the comments below. If you enjoyed the video, don't forget to like, share, and subscribe to our channel. Also, click the next video on your screen for more.